Hi friends, welcome to my channel Maths Academy by DG. Today we are going to continue chapter number 2 ITF. Okay, so ITF is nothing but what? Inverse trigonometric functions. Okay, the weightage for this chapter is 1 plus 2 into 2 plus 3 is equal to 8. Means totally 8 marks we are having in a inserted board. Okay, so now this is the first lecture, means introduction class for ITF. So students, remember one thing, this is the very important for objective also. Okay, because of whatever the concept I am going to continue in this, that concept again we can use in what objective level also. So one mark also we are having from the chapter, means remember this chapter is very important for us to get the 100 marks in NCERT. Okay, so that's why. So now I will start the class. In this, see f, ITF among this, what is f is nothing but it is a function. Yes or no? F is nothing but function. ITF is nothing but inverse trigonometric function. See, first we can discuss the function. Before going to start the inverse trigonometric function, first we can learn what is function. Yes. So after that we can learn trigonometric functions. Then in the last we will start the inverse trigonometric functions. Okay, see, we have completed in the first PUC, means 11th standard, sets, relations, functions. Yes or no? So just I will recall the function. Suppose f is from a to b, it is, we are going to say function if every element of set A, every element of set A has one and only one image in set B, then we can say f is a function from A to B. Remember this definition. Already I have completed. So 11th standard functions concept. So once again I am going to recall this because it is required to start the inverse trigonometric functions. So every element of set A has one and only one image in set B. Means just I will take one of the example to give the explanation about this 1, 2, 3 elements in set A and set B contains some A and B elements. Okay, if you are taking A and B element, the function is mapping from A to B. One which is mapping with B and 2 mapping with A and 3 mapping with B. Okay, see whether it is a function or not. Definitely it is a function because of every element of set A has one and only one image in set B. Yes or no? Yes, see once again, one having the image is A and 2 having the image is B and 3 having the image is what? Again B. Means every element having only one image, we will say this is the function. This is the concept about the function. Okay, so after that, so you have completed the concept of the function in the 11th standard also. Again, just I am giving the explanation about the definition, that's all. So next we will take the T is nothing but what? Trigonometric. So TF, trigonometric functions. Okay, we know that the trigonometric ratio chapter, in that having the trigonometric ratios. Okay, so we know that the 6 trigonometric functions are sine, cos, tan, cot, sec, cosec. These 6 trigonometric functions are there. Okay, so these 6 trigonometric functions are there. So by using this 6 trigonometric function, so today we are going to continue inverse trigonometric functions. Okay, first we can I will explain this 6 trigonometric function, what is the domain and what is the range of this 6 trigonometric function. Then I will start the inverse trigonometric function. Okay, so just I will rub this 6 trigonometric function domain and range. Sine function, by taking the sine here, sine function domain is R and what is the range of this? -1 to 1. Yes, again we are taking the cos function, same, which is similar to the sine. After that tan function, by taking the tan function, that is r minus, I will write x such that x is equal to 2n plus 1 into pi by 2. N belongs to z, tends to r. Yes. And the next one is Cot function. Cot function is r minus, again I will write x such that x is equal to n pi, n belongs to z. Yes. And r minus. Okay. Next, tends to r. Next, after that, next again I will write sec function. If you are taking the sec here, r minus, again the domain of secant is similar to the tan. So x that x is equal to 2n plus 1 into pi by 2. So n belongs to z. Yes. Next, what is the range of this? It is r minus open interval minus 1 to 1. Again, the cosecant function is it is the last one. So I will write this. See, r minus. So the domain of cosecant is cot. C. Remember, so domain is C. So x says that x is equal to n pi. N belongs to z. And what is the range of this? Range is similar to this secant. Okay. So these 6 trigonometric functions are having the domain and range here. Okay. So after this, one by one I will take here. Suppose we are taking the sine function. Okay. If we are taking the sine function, just I will draw the graph of this. Okay. So then I will say when the inverse trigonometric function will be exist. Okay. So first I am taking the graph of this sine function. See once again. So x-axis, this is y-axis 0. This is the pi by 2. This is the pi, and what 3 pi by 2, 2 pi and 5 pi by 2. Remember, so this is a very important graph. Okay, already we have completed in the first PUC, means 11th standard. Once again I am going to recall this, means which is a very important. Remember, see, this is the graph of a sine function. Roughly I am taking here. Now suppose we are substituting the sine anti which will give the 1, and what is the minus sine anti? Again minus 1, like this. Actually, see, just I will rub this. Wait, this should be equal. Yes. So this is the rough graph, that's why I am taking here. So minus 1. This is actually minus 1. Next we will see like this also. Yes, it is the correct one. Okay. Now see the graph of this here. What is we are observing in this, means sine 90 is giving 1, and sine 5 by 2 also what giving 1, and sine minus pi by 2 giving the minus 1, and sine 3 pi by 2 value also again what minus 1. So in this graph we are observing, and one more thing, by substituting these all are the real numbers on x-axis, we are taking all the real numbers are domain. Yes or no? Domain is nothing but all the real numbers. All the real numbers we are taking on x-axis, that is indicate here domain. Okay. Now by substituting in this, so definitely we are having the result is, see, the result is in between minus 1 to 1. So that's why we are going to say range is minus 1 to 1. The range of sine function is from where to where? Minus 1 to 1. Remember this. Okay. So now one more thing I am going to see here. Suppose if we are going to say this sine function is a 1 1. This is a very important line I am going to see here. 1 1 function. After this onto function, then we can define the bijective function. After we will start the invertible function. Okay. So see the function, if you are taking this sine, it is a function, yes. But if we are going to define the inverse trigonometric function, this sine function should be a 1 1 function, onto function, and bijective function. Okay. So now I will see here. So by observing the 1 1 function from this domain R and range minus 1 to 1, whether this sine function at domain R which is giving the 1 1 function or not, we will check. So actually what is 1 1 function? Means just I will take here the 1 1 function is, all of you copy this one. Okay. Just I am going to rub this one. So see, the 1 1 function is actually, if we are taking the 1 1 function, this is actually functions concept again is having in the second PUC also, means 12th standard. Okay. What is 1 1 function, what is onto, this is actually 12th concept. Okay. So now by taking the 1 1 function here, So suppose every element, just I am taking the example, A contains 1 to 3 elements and B contains A, B, C elements. Okay. See, now I will write here function from A to B. So every element, or simply we can say different elements in set A having the different images in set B. Different elements in set A having the different images in what? Set B. Then we can say the function is a 1 1 function. Okay, means remember 1 which is mapping with B, 2 mapping with A, 3 mapping with C. So different elements in set A having the different images in set B. So we can say this is the function. 1 having the images B, 2 having the images A, 3 having the images C. Suppose I am taking one more example, then only you will be understand when the function which is not what 1 1. So after here, just I will take one more example. See, 1 2 3 elements are there, A and B. 1 mapping with B, 2 mapping with A, 3 mapping with B. See whether it is a 1 1 function or not. Sir, what is the definition of 1 1 function? Every element of set A having the different images in set B. Okay, having the different means different elements in set A having the different images in set B. So 1 which is mapping with B and 3 also mapping with B. Yes, different element in set A, 1 and 3 they are different elements in set A but having same image in set B. Yes or no? B it is a image of 1, B it is a image of 3. So we will see here it is not a 1 1 function. Remember this. Okay, so it is not 1 1. So now this is what 1 1. Okay, this is the difference between the 1 1 function, and there is a one formula also having for 1 1 function. Suppose f of x, we know that f of x is equal to y, we can define the function like this. Okay, if we are taking this is the domain element, this is what codomain element. So x1 comma x2, the two are the two elements from the set A domain. Okay, we will write here f of x1 is equal to f of x2, implies that x1 is equal to x2, then only the function is what 1 1 function. Okay, so next see I will start the what from this only I will give the explanation about the sine function, whether it is a 1 1 or not. Okay, so see now, so just now I have completed the 1 1 function. Okay, so now see here from the sine, when we will say the function is a 1 1, actually with respect to the domain of R for this sine function, whether it is a 1 1 function or not, just I will give the explanation about this. Okay, now whatever the values are present on x-axis, these all are the domain of sine function, because of R is nothing but what real number. Okay, so these all are the real numbers. Okay, what are the pi by 2, pi 3, pi by 2, these all are what domain elements. Okay, so now suppose we are taking here x is equal to minus pi by 2 or simply pi by 2. Okay, so sine pi by 2 giving the result is what 1, and sine 5 pi by 2, yes sir, sine 5 by 2 also 1. Okay, so just now I told what is the 1 1 function means different elements in a set A having the different images in set B. So at x is equal to pi by 2 having the sine value is 1, at x is equal to 3 pi by 2 also having the sine value is what 1, means I will write simply here see 0 minus pi by 2 minus pi by 2 3 pi means pi 5 pi by 2 like this. Okay, then I will take the value is definitely will be getting between minus 1 to 1, so 0. Okay, so like this simply I am writing some values 0.5 like 0 minus 0.5. Pi by 2 value is 1 and sine 5 by 2 value also 1. See, different elements having the same image or not. Pi by 2 it is a different to the 5 pi by 2 but having the same image, that is what 1, means we will say here the sine function at with respect to the domain R which is not a 1 1 function. Okay, suppose which is not a 1 1 function, remember which is not a bijective. Sir when we can say bijective function means remember function should be a 1 1 on 2. Okay, then the function is called what? Bijective function. If the function is a bijective, then the function is exist for inverse. Okay, then only we can define the inverse trigonometric functions. Okay, so this is the interconnection between the 1 1 on 2 and bijective function. So that's why, so one, if the function it is not a 1 1, remember it is not a bijective. Okay, so that's why just I am going to change, making the changes in this. When we say the function is a bijective means, so just we are taking in between minus pi by 2 to pi by 2. Remember that. Okay, we are not taking total values here. Just we are taking what? Minus pi by 2 to pi by 2. In between minus pi by 2 to pi by 2, see the values we are having minus 1 to 1. So in between the values won't be repeated, like for pi by 2. For pi by 2 we are having 1, and for pi by 2 also we are having what? 1. So like that, in between minus 1 to 1 means, so minus pi by 2 to pi by 2, the values which are giving what? On the y-axis directly minus 1 to 1, means in between we are not having the repeated values. Okay, means distinct element which are having the distinct images only. So we will say that is a 1 1 function. So that's why I am taking the interval in place of r minus pi by 2 to pi by 2. This is one of the branch we are taking. There are so many branches are having. So in this we are taking one of the branch minus pi by 2 to pi by 2. In between the function sign giving what? Function is a what? 1 1. Okay, definitely the function is again onto. So what is onto? Remember that actually onto is nothing but we'll say f of x is equal to y. So what is f of x? It is a range. And what is the y? That is codomain. Okay, so if range is equal to codomain, will we say function is what? Onto function. So that's why minus pi by 2 to pi by 2, you can substitute this is actually what? Now I am taking the domain s. Sine function we are going to define here, we are taking simply domain. Okay, so now by substituting the values again we have to get minus 1 to 1. Okay, this is the range. Now we will substitute all the values, again we will get what? Minus 1 to 1. So we will say in this interval minus pi by 2 to pi by 2, again the function sine which is giving what? Onto also. So now I will say sine is from minus pi by 2 to pi by 2 to minus, range is minus 1 to 1. Sine function it is a 1 1 and onto also. So I will give the brief note about the 1 1 and onto bijective function in the relations and function chapter. Okay, this is actually inverse trigonometric function. So that's why I am taking the little bit concept about the 1 1 and onto. Okay, but one more thing I am going to say in this, what means if the function with sine function it is a invertible function, means definitely it should be a bijective. Remember, and if the function is a bijective, function should be 1 1 and onto. Okay, if the function is 1 1 and onto, function is bijective. Okay, the definition of bijective function is the function is 1 1 and onto, then it is called what? Bijective function. Okay, if the function is bijective, so we will say there what? The function which is what? Invertible. Okay, so all of you able to understand. Okay, see, now we are taking the function, we are not taking now the sign from r to minus 5, minus 1 to 1, r is from minus 1 to 1, just we are taking in this inverse trigonometric function, so minus pi by 2 to pi by 2 only. Okay, we are not taking here r. If we are taking the r, what is the reason of these two? Means if we are taking the r, in this having all the intervals, all the branches will be there. Okay, in all the branches again the value pi by 2, 5 by 2 having the same image, their function is not 1 1. If it is not 1 1, which is not defined for inverse. Okay, so that's why remember sine from minus pi by 2 to pi by 2, given the range is what? Minus 1 to 1. So now in this interval the sine function which is bijective. Okay, suppose the function is a bijective, remember the function is invertible. Okay, if you are taking the f is from a to b, yes sir, it is a function. If we are taking this function f is from a to b is a function, it is suppose 1 1 and onto, then it is a bijective. Remember, if it is a bijective, it is exists for what? Inverse. Exists for inverse. Okay, how we can denote this? Yes, f inverse. We can denote for the invertible function like this. Okay, inverse of f is like this, f inverse. Okay, and the places will be interchanges. Okay, the codomain, we will take the place as a domain, domain take as a codomain. f inverse from b to a. This is the invertible function. Okay, so I am taking here also, see, f now sine function is from minus pi by 2 to pi by 2 to minus 1 to 1. Okay, if we are going to say this is the bijective function, yes sir, no doubt it is a bijective function. So then it is exists for what? Inverse. How will write the inverse? Means this is the, we are writing inverse. This is nothing but what this the donation. What I am going to donate here means the inverse trigonometric function. Okay, so inverse sine function, we can read like this: inverse sine function. Again the places will be interchanges, minus 1 to 1, and what is the range of this? Minus pi by 2 to pi by 2. What is the domain of inverse sine function? Means minus 1 to 1, means places will be interchanged like this, b to a. Okay, actually f is from a to b, which is interchanges b to a. This is the inverse trigonometric function. There are total 6 inverse trigonometric functions are there. So in this class just I have completed only one, that is what? Inverse sine function. Yes, the inverse sine function, which is from what? Minus 1 to 1 to minus pi by 2 to pi by 2. Okay, now suppose we are taking here, some student they will be say, sir, why we are not taking, sir, pi by 2 to like we can take, sir, 3 pi by 2. Yes, this is again one of the branch. In between also we are not taking the repeated values, means same images we are not having in between pi by 2 to 3 pi by 2. So we can take here pi by 2 to 3 pi by 2 also, remember. Okay, so this is one of the branch. In this branch also sine, which is a bijective function, again the inverse will be existing in this branch also. Okay, so the remaining part we can continue in the next class. Thank you.